Hello everyone, my name is Jose Santos. I am a grad student at the University of Arkansas and I am a teaching assistant for the Electromagnetic Supply course at the University of Arkansas. We are going to go over a problem on SmithChart in which we will solve for some parameters like the reflection coefficient, the standing wave ratio, the input impedance, and a matching network. For this problem, you will need a blank printed SmithChart. Also, you will need a pencil because we will draw some lines and some points in the SmithChart. You will need an eraser as well in case you make any mistakes. You will need a straight edge or a ruler because we will draw some lines and take some measurements in our SmithChart. And you will need a compass because you will draw some circles in order to express all the calculations on the process for solving the problem. So let's take a look at the problem. It says that we have a lossless 50 ohm air transmission line that is terminated with a load with the impedance of 75 plus J100 ohms. The frequency of our generator is 3 gigahertz, and we need to use a SmithChart to determine the following parameters. In the first part, we need to determine the reflection coefficient, both the amplitude and the phase. So the first step in any problem is to know what are our givens. So let's write down what our givens are. So we are given a lossless 50 ohm air transmission line. This 50 ohms represents the characteristic impedance of our transmission line. In other words, it will represent the Z0. We are also given the load impedance. So let's write that down. Any impedance that we represent in the SmithChart will be the normalized impedance. So we need to normalize our load impedance. That will be done by dividing our given load impedance, which is the capital letter, by the characteristic impedance of our transmission line, which is C0. That will give us 75 plus J100 ohms divided by 50 ohms. If we plot that in our calculators, we will get a normalized impedance of 1.5 plus J2, and this is the one that we will plot in our SmithChart. We also need to write down that we are given a frequency of 3 gigahertz, and those are pretty much our givens for for this problem. Let's solve the first part of our problem. We need to find the reflection coefficient, both the amplitude and the phase. Since we have already our normalized impedance, the first step to find the reflection coefficient is locate this impedance in the SmithChart. So let's do that. In our SmithChart, we have two axes. The horizontal line will represent the real part of our load impedance, or any impedance that we will plot in the SmithChart. And the axis that goes all around in the circle, both in the top part, in the lower part, that will represent the imaginary part of the impedance that we plot in the SmithChart. In the top part, we will represent the positive value for the imaginary part of any impedance, and in the lower part, we will represent the negative value of any impedance in the SmithChart. In our case, we have a normalized impedance of 1.5 plus J2. So the first step is to find where is this real 1.5 in our SmithChart. So in here we have 1, we have 1.2, and we have 1.4, and we have 1.6. However, we are asked to find 1.5. So 1.5 will be the line between 1.4 and 1.6, which is this one. That 1.5 will represent all the impedance in this circle. So we will need to find the other part, which is the positive 2J. Since it is positive, we will locate it in the top part of our SmithChart. So let's find where in this axis is this positive 2. As we see here, we have 1.8 and 2. This is the number that we are looking for. And the impedance, the normalized impedance, will represent the intersection of this line coming from these two and the line coming from the 1.5. So it will be this point right here. Again, our normalized impedance will be the intersection between the 1.5 and the J2 ohm. Now that we located our normalized impedance, we need to use that point to draw our SWR circle. In order to draw our SWR circle, we will put the needle in the center of our Smith chart and we will use the point to determine the radius of that circle. So let's do that. Now that we have drawn our circle, we need to draw a line from the from the center of the Smith chart, passing through the point and to the outside. Like this. The circle will help us to find the magnitude of our reflection coefficient, and the line will determine the angle of the reflection coefficient. Let me put some colors to the circle so you can see it better. And also to the line. Now we can go ahead and calculate the magnitude of a reflection coefficient. It will be determined by the ratio between the inner circle, the radius of the inner circle, and the radius of the overall Smith chart. So in our case, we need to measure our SWR circle radius. That will be around 5.2, and we can write that down. Now we need to measure the radius of the other circle. That will be around 8.2 centimeters. We plug this into our calculator and we get a value of 0.634 for the magnitude of the reflection coefficient. Now, in order to find the phase of our reflection coefficient, we will look at this axis that says angle of the reflection coefficient. It starts from 0 here and it starts increasing 10, 20, 30 in this direction, and in the same way it starts increasing but in the negative direction, negative 10, negative 20, negative 30. Since our line is cutting the line, the Smith chart circle, in this position, this is the angle that we need to read. So it will be, we have 30 here, 32, 34, 36, 38. So the angle of our reflection coefficient, the phase, will be 38 degrees. And we can write that down. The overall reflection coefficient will be 0.634 with a phase of 38 degrees.